Yeah, I know, it's this program again. So what's the problem this time? I'll just show you my code so you know what's going on for the updates here. There's nothing special there. Nothing really changed here. That's interesting. What happened to all that HDC and select object and HBitmap stuff? That's interesting. That's not there anymore. Something strange there. So, okay, maybe you thought I might have found a replacement to StretchBlt, right? Well, I guess we'll have to see this part here. Oh my goodness, what's with all these local variables? My goodness, that's a ton. Wow-wee, what's with all the local variables? Well, there's actually a good reason for that. I actually solved the problem. I had you fooled for a moment, didn't I? But anyway, I just thought I'd show you what my solution is. Okay, so maybe I have found a solution to StretchBlt, or a replacement anyway, that doesn't write into video memory. Well, that's actually not the case. I've actually figured out how to do it manually. Oh, so I got 96 gigs of memory on my system? Oh my! Well, nope. I only have 3 gigs of memory. Well, actually I have 4, but only 3 gigs are actually effective due to a 32-bit OS limitation, if you know what I mean. However, I've actually figured out how to do it manually. And if this is any hint, pixel credits? Huh? What is that all about? Well, it's just, I'll have to explain the system. Stage 1, crop the source image. Well, you probably remember that from how I processed the ground, right? And how I ended up cropping it first thing, you know? Well, that's pretty much what this does. Yep. Lots of loops here. Yeah, loop within a loop. That's nothing new. Of course, I've had loop within a loop within a loop. But that's stage 2. But notice my programming style here and how I use stage and then something. It's just, think of it this way. A stage is a level in a video game. Complete a level, you're a little bit closer to the end. Complete a stage in the programming, and I'm a little bit closer to finishing this game. Get it? Well, that's pretty much what the cropping is. It's really nothing more than logging positions, of course. But this is only for my needs. Of course, I know how to do it on all 4 sizes necessary. Stage 2. Scale the cropped image horizontally. Why only horizontally? Why not vertically? Well, there's actually a reason for that. First, horizontally, doing it horizontally first, not only is it easy, but it's also, as a bonus in a way too, I don't have to use as big of an array size or anything like that, if that 24 megs is any hint. However, yep, and here's this one here. Look how little memory I need. 96 gigs? I don't even look close to 96 gigs to me. Not even close. And, let's see. Where was that source one? This is the original. Even that's nowhere near 96 gigs. Not even close. Although I could write a program that would write 96 gigs of data, if you know what I mean. Or at least 96 gigs in a single image, if you know what I mean. But hey, there's no real point in doing that. Aside if I'm after testing hard drive speed. That's the only thing I'd be good for. But anyway, yep, stage 2 is where I crop that. So what is this credits thing all about anyway? Well, let's consider an example here. Well, one of the ratios that I happen to have is 87 to 64. I'm going from 87 to 64. That's the kind of scale down I'm going with. That means the original is 87 and my new one is 64, in case you're wondering. I start with 87 credits for this particular scale ratio anyway. Each pixel is going to take 64. Each full pixel, that is. Yeah, that's right, full pixel. As in, there's fractions of a pixel supported. That's kind of interesting. Fraction of a pixel? How's that possible? Well, it's indirect. However, think of it this way. You got 87 minus 64, or dash as I often like to call the subtract sign, because, well, what does it look like? But anyway, 87-64 leaves 23. And this is the part where that little leftover from the previous one is used with, but in this case it always starts with a full. And this here is for modulo, or remainder of a division, in case you don't know what that is. You know, 87 divided 64, you end up with a remainder of 23. 87 mod 64 is 23 as well, if you know what I mean. So, that means I got 23 left over. Of course, this while loop wouldn't otherwise take effect because, well, 23 is less than this, which would actually be the 87, if you know what I mean. So, let's see. So that otherwise ends up going into here. Which, now, what about the second pixel, the one immediately to the right, or in the case of vertically, yes, there is a vertical in there, that's a must. So, what about that then? Well, that's actually pretty easy. 64-23, and I'm left with 41. 41 goes for this. So what's left over? But 46, if I do the math right. Yeah, 46, okay. So for the next pixel, I got 64-46, or 18. Okay, so that's 18 here. 87-18, 69. Hey, that's more than 64, so I get a whole pixel's worth that time. So I dash another 64 and I get 5. And that process just keeps on going, and that's pretty much how I figured out how to scale it, an image. And just as I was going to bed on March 18, and by the way, that's like 7 a.m., which is nothing new for me. Yeah, that's right, a.m. I don't have the exact time. Let's see. Well, it's not important anyway. But either way, yep, I got the vertical next. And this one actually took me 3 hours to figure out. It was mostly this part here in brackets. This is where I calculate the array index. Yeah, vertical is much more complex because of that, if you know what I mean. And this is here to offset for that too, of course. Yep. And what caused me a lot of problems is the fact that this was like that. That really threw me off big time. Wasted almost a whole hour or an hour and a half because of that. Yeah, subtracted instead of added. Boy, that gets so annoying. Yep, and then stage 4, crop the resulting fully scaled image and, if necessary, tile it. Okay, so how do I know if tiling is done? Well, that's really easy. It's already calculated up there somewhere. Yep. Okay, and that's pretty much all that there. That's how the tiling is done. I only need it on one axis. And this is where the output is written, which is really nothing new. This is the byte position for where that particular part of the image header is stored. So what's with all this commented out areas here? As per these things here, those are comments. That's comment start. This is comment end. Of course it's contiguous because, well, that's this here. Of course if I put that in there, it's nice and clear. Put one here and, well, it's not. Stuff in green like this is commented out. Or at least that's how I've configured it. You can change the colors in this particular program. If you want, anyway. But anyway, this is what I use for testing to see if the cropping is working right and see if the scaling is working right. The one I spent 3 hours figuring out is this, because it was oddly skipping pixels or duplicating pixels the wrong way. And all kinds of screwy things. Yeah, I know, class 4 and class 5 bugs are just not fun. I even had 7s during all this. Unhandled exceptions are almost always a 7. That's quite high on the severity list. They might actually even be potentially 8, but at least debug might help kind of block that in a way. But anyway, that's the full code. Or is it? Yeah, there is a problem. Still. Boy. Okay, so maybe you weren't so fooled after all. Just in a different way. Well, actually, nope. It is a problem, yes, but it's one that I easily know how to solve. I need to get 192 calls of this, copying data from my spreadsheet here. Oh boy, that's gonna take a while, wouldn't you think? Wrong. I have a handy shortcut. I'll show you my shortcut. This looks like a mess. Looks kind of strange too in a way. So what is with all this? Well, it's actually pretty easy when you think about it. Okay, notice this up here? But it's cut short. And all these other things in here, and where's the equals some particular cell and stuff like that at in here? Well, that's actually because this is highly constant. It rarely changes. If you saw that anyway. However, I'm going to make use of a shortcut. One that's extremely useful and powerful. It's actually real easy. Copy. Open up Notepad. Gotta find it. Paste. Delete. Copy that. WordPad. Why am I opening up WordPad now instead of Notepad? Easy. Copy this again. Okay, and I'll replace that. Oh, that's why. And that's the reason why I do that. I can't have a table like that. So what's the shortcut then? What's with all this? Well, I need to replace all these tabs here. And that's where this comes in handy. There's just one problem though. Oh boy. Press tab, and how am I going to replace tabs now? Well, there's actually a way, and I'll show you how. First, you select them, then you copy them. Replace the... That looks weird. Okay. Yep, it's actually because it's not an ASCII character from the 0x20 to 0x7e, I think is where it stops, or 7f. Probably 7f. But I put in a space here, so both these tabs together are done. Why both at once instead of just one? Easy. If I do just one, all these tabs are going to have the same effect, and that's not what I want. By doing two, I can special do them. That way the ones will get skipped because it's not a pair of tabs. So, replace all. Now all the doubles are spaces. Now all those doubles are spaces. But that's not what I need yet. It's not quite all the way there. Delete one of the tabs. Yes, you can do it that way. Delete that space so there's nothing in there. Replace all. Hey, this looks a lot more like it. Except there's a dot here. What is that all about? Well, that's easy enough to get rid of. Change that to a dot. Replace all. And it's all set to go. Wow. 192 done that quick. Amazing, isn't it? Yep, and you even got those double zeros changing from triple to double like that. So, I'm going to copy that and find the right thing, of course. And paste that in there. No indentation. That's quick. Real quick. If this is any hint. Yep, and that's it. It's all done. That quick. That's how you do 192 things at once. Got 1,000 things to do? 10,000? Same trick works. Very powerful shortcut. Make use of it whenever you can. But what about executing it? Well, I have done a few test cases. Yes, that is actually a texture there. You can see that. Here I'll get a little more visible. These are my older tests that I've done. But yep, that looks otherwise like it would have done manually, aside from the cropping, of course. I just had all these test cases here for getting that working right in the first place. Yep, some screwball ratios here. So, now to process everything, I first need to delete these. I don't need these anymore. Of course, I could just leave them as is, but that's no big deal. I need this one, though. Looks rather smooth looking. But that's for a reason. This program likes doing that for some reason. Yeah, it's this. It's the default whenever I open up image files like that. But this is that massive grass texture. Very well done one, too, by the way. So, I'm going to run the program. Hopefully I don't get any errors. Hey, no errors. Nice. Run. Uh-oh, looky here. That's a class 7 bug. No source code available, so where's the problem at? That's a first. I haven't seen that happen before. Okay, so I guess I'm going to have to debug this, see what's going on. I'll just start here. Okay, 11. Things are good here. Okay, execute. And it still happens on that first one. Why I get this, I don't know. I don't know how do you work with that. So there's probably some unknown problem in here somewhere now. And which means I'm going to have to delete part of this video out and cause a sudden jerk. So, go to the top of this and go down the list. All this doesn't have problems. I'll do another method anyway. So, let's see. Does the cropping work properly? Handling already here. So, I don't know where this is happening at for some reason. So, it's happening in some other location, and I need to figure out what's going on.